Hi, welcome back to EducateTube.com. My name is Sipsky, your host. In this video, I'll be showing you how to build your very own lithium iron phosphate power bank system. As you can see here in my hand, I have a 190 watt-hour battery. If you pair it with your fast charging USB car charger, you'll be able to power your LED light or your smartphone. I'll show you how to do it and what material you need. Let's get started. All right, so let's put it together. I have this lithium iron phosphate battery that's 190 watt-hour. Now what I want to do is I'm going to connect it to my car socket, and then I'll connect it to my car charger. Okay, so what you need is the battery. I'm going to show you how to build that in a minute, but let's assume that you got the battery done. And you want to connect the positive and negative terminal to each end. So I have an alligator clip that'll connect to the positive. There we go. And then the negative right here. Notice the alligator clip is connected to a larger alligator clip that has a car socket right here. Okay, you can see there. And what you want to do is take this fast charging USB-C or USB car charger and you connect it like that. And you'll notice it's saying that it's 13 volt in this system, so it's pretty good battery. And if I want to, let's say, light up my USB LED light, so here we go, let's plug it in, and there we go. See that? Pretty cool. Now I have light, okay, using the USB connector. If I want to connect to my smartphone, all I have to do is get my USB-C. Where is it? Let me grab one of those. There we go. Connect it like that, and then plug into my smartphone. Okay, and voila. Okay, and it's charging right now. So that's how you do it. All right, let's build a lithium iron phosphate battery. We're going to build two versions. One is 6.4 when we combine these two lithium iron phosphate battery together, and the 12.8 volt version, which is 4 cell connected in series. Okay, let's start with the 2 cell first. Let me turn this off. Okay, so you notice that I have this lithium iron phosphate cylinder type of battery. This is a 33140 type of lithium iron phosphate battery. It's a 3.2 volt, 15 amp hour battery system. This is a lithium iron phosphate. I think the model of this one, or the type, is the 33140. Okay, that's the type of lithium iron phosphate battery. So it's a cylinder type. It's quite big actually. What we want to do is be able to connect it in series. So I notice I labeled positive, and the back here the negative. So what we want to do is rotate the positive and negative together. I will use my nickel metal strip, and I will use this pulse welding to solder it together. Okay, so we'll weld it together, and then we'll use my variable power system to charge the battery, and I also use the voltmeter to determine the voltage once I fully charge the battery. All right, let's do that right now. Okay, so we're going to build a 6.4 volt, and we're going to charge it all the way up to, let me see, around 7.2 volt or 7 volt. And this is good enough to power a LED lights. So anything that's a lighting system, because LED light requires around, if you're using a USB, around 4 volt all the way to 6 volt. So this is going to be good enough. Okay, so we're just going to use it for just lighting, not for charging smart devices, but just for lighting. So let's do that. Let's turn this on. Let me get my safety glasses first. All right. So here's the welder. And oh, I need to see if I can show you. There we go. Okay. So using the nickel metal strip, we're gonna solder it together. Let's do this first. Okay. Okay. Then let's solder this together. I'm just gonna quickly tape it together, just for now. Okay, just tape this. Now notice I don't have the BMS connected. For a small cell like this one here, this is a 50 amp hour. You probably won't need it for these 2 cells. Okay, if you're doing 4 cell, you might need it, but I actually didn't use it because I manually monitor the voltage for each of the cell. Okay, so I would charge it all the way up to maybe 13.8, 13.9 volt for the 4 cells, and then I'll check the individual cell to make sure it doesn't surpass 3.65. If I determine that to be true, then I know that my maximum voltage that I would charge for that 4 cell battery would be 13.9. Okay, if it goes beyond that, I have to make sure that I reduce the charging to maybe 13.6 or something like that to make sure I have balanced all the cells. Okay, but for now this is okay. Let me check quickly the voltage for this battery. It should be at least 6 volt. Let's see what it is. Yeah, so 6.6. Wait, hold on. 6.65. So 6.65 means that its hold is charged quite well right now. I'm going to bring it all the way to 7 or 7.2 volt because each of the cell has a maximum voltage that you can charge all the way to 3.65 for lithium iron phosphate. So I'll see if I can do that. Let me measure individual voltage for each cell. Let's see. Okay, this one is 3.32. This one is 3.32. So both of them are pretty good. They have 3.32 volt, which means that they're pretty good for connected together. What I want to do is now I will solder the positive negative terminal to extend the terminal so I can connect my alligator clip to it. So let's do that. Let's see if we can cut this. There we go. Let's weld it together with my pulse welder. Okay. All right, so now I have completed the welding of the 2 terminals. I can now add the alligator clip. So let's connect the positive end and then the negative end like that. All right, so since I'm going to use this lithium iron phosphate battery, the 6.4 volt, or you can say it's can be charged all the way to 7 volt system, I will have to connect my car plug. This is a standard one, and you can see there's a light here. So if I plug my light into it, it should light it up, because remember the LED light, when you have a car plug, as long as there's at least a 4 volt that's running through it all the way to 12, it should handle it. For example, we have a 6-7 volt system. We plug this in and voila, see that? It will light it up, no problem. Same thing here if I have the 4 light system that's connected in parallel for the LED light. Here's USB, and let's see. Oops. There we go. You can see it's lighting pretty well. Okay, so for the 7-volt or 6-volt system, you can connect it together for your lighting system. This is good enough if you want to power your lighting system. However, if you want to connect your smartphone and smart devices, I think you need to build a 4-cell system like this one here. Then what you're able to achieve is that you can get a 12 to 13-volt system that can power your smartphone and smart devices. Okay, so I'm not going to show you right now because it's very similar concept. You just have to connect the positive negative terminal to one end, and then you connect that in series, and you open the 2 terminal for positive negative, and this is where you connect it to your car socket connector, and then that is connected to your USB fast charging car charger. Okay, and you're able to power any devices you want. All right, now to charge the battery itself, like this one here, the next thing you want to do is grab your variable power bench. So this one I have right here, and you connect the positive, and then you connect the negative terminal to that, and then turn on your variable power bench, and you set it to, let's see, I want to set this to, because the maximum voltage in each of the cell is 3.65, right? And it's connected in series. You're looking about 7.2 to 7.3 volts. I'm going to actually set it to just 7.1 just to be safe. I don't want it to overcharge my cell and ruin it. If you overcharge this cell, it can actually ruin the cell over time, right? So I would say it's better to keep it to around 3.5, 3.4 voltage in each of the cell, and then you can recharge it multiple times, okay? And it will last much longer. Whereas if you overcharge it, over time these cells may not work properly. So it's better not to overcharge this battery. I would say if you want to charge it all the way to 3.5, 3.6 volt, not above that for each of the cell. And when you connect in series, maybe charge it to 7 to 7.1 volt. And that's what I'm going to do. I'm going to set it to 7.1 voltage. Let's see. There we go. 7.1, okay. Negative terminal, and then positive terminal. There we go. So now it's charging. So it's charging right now. Initially it was 6.65, which is already great, right? But I want to bring it all the way to 7.1, and maybe this will take maybe a couple hours for it to fully charge, and then I'll hook up to my lighting system. So this battery is designated just for lighting, for powering my LED lights, whereas this device can power my smartphone and smart devices. So yeah, it depends on what you want to build it for. If you want to build for the lighting system, you'd use a 2-cell. If you want to build a system that can power your smartphone, smart devices, and even your small laptop or tablet, you want to build a 4-cell system that can handle it. All right, I hope you enjoyed this video. Don't forget to subscribe and give me a little heart of appreciation. I'll talk to you soon. Bye.